Okay, let's take a look at this example. This one's just a little bit more difficult. So we're asked to find dy over dx for this equation. Now, I want to take the derivative of the left side. Okay, so let's take the derivative of the left side. I'll notice that it's actually, I need to use a chain rule because our inner function is not just x, it's x minus y. So let's take the derivative of x minus y. Well, the derivative of just x is 1. The derivative of just y, well, that's 1 again. But since I took the derivative of y, I need to add that dy over dx part. Okay, and then the derivative of the outside function is e to the x minus y, so let's just put e to the x minus y. And this is equal to, let's take the derivative of the right side. The derivative of this is 4x to the first, and the derivative of this would be minus 2y, and because I took the derivative of y, I need to take the dy over dx again. Okay, so let's go over that again. So when I took the derivative on the left side, what we did was we noticed that we have an inner function. So I took the derivative of x, which is this 1. I took the derivative of y, which is just 1. But since I took the derivative of y, I need to include that dy over dx. And then let's take the derivative of the outside function. Well, e to the x is a special function where the derivative is itself. That's why it's just e to the x minus y. And it's equal to the right side. Take the derivative of this. Well, that's 4x. Take the derivative of this. Well, it's minus 2y. But since I took the derivative of y, I should include this dy over dx. Okay, now because I need to take the derivative, I need to find dy over dx, now it just becomes an algebra problem where I need to isolate dy over dx on the same side. So first thing is I'm going to expand the left side. So if I distribute the e to the x minus y, we get this on the left side. And on the right, it's still the same. But now I need to get all the dy over dx's on the same side. So I'm going to add this onto this side and then subtract this onto the other side. Okay, so then if you notice on the right now, I have two terms with the dy over dx. Guess what? I'm going to factor that out from both of these terms. So then we're left with, I'm left with e to the x minus y minus 2x, since I factor out dy over dx from both. And this is one last step now because I want to isolate this, right? So what operation is happening with the dy over dx and everything else? This is a product, so I'm going to divide this out on both sides. And we get the quotient of the quantity e to the x minus y minus 4x all over the quantity e to the x minus y minus 2y. Okay, what I want you to do now is just take a second and review everything that we've done. Okay, so what I want you to try on your own is I want you to find dx over dy for y to the fourth plus xy equals x to the fifth minus 7x to the third plus 1. Try that on your own, and we'll talk about this more in class. And another thing that I want you to note is when I'm asking you to find, notice this is different than what I have shown you, but you can still do it using the same process. Just think about it a little bit more. And also answer this question. Why do we use implicit differentiation? And no, the answer is not just to make life harder. Okay? Actually give that some thought. I'll see you tomorrow.